Okay, in this video we are looking at factorising a quadratic expression where the coefficient of x squared equals 1. There will be a follow-up video where we look at factorising a quadratic expression where the coefficient of x squared is greater than 1. Okay, if you just look at this example here to remember when we expand double brackets, okay, we've got two terms x plus 5 multiplied by these two terms x plus 2. Remember, everything in the second bracket must be multiplied by everything in the first bracket from our previous video. So x times x gives me x squared, x times the 2 gives me 2x, plus 5 times the x gives me plus 5x, plus 5 times plus 2 is plus 10. And then we collect the two x terms in the middle, plus 2x plus 5x is plus 7x. And there we have a quadratic expression. Well, factorising a quadratic expression like this is turning it back into what it started as. So we need to take this expression here and put it back into brackets as it was to begin with, because factorising, as you know, is the opposite of expanding a bracket. Okay, so the question is, how do we do that? Well, I've got a little table here which I'm now going to bring up. Okay, so let's have a look at this table, and I want you to look at it for a few seconds to see if you can spot any patterns. Okay, if you look on the left hand side, we've got 1, 2, 3, 4, 5, 6, 7 sets of double brackets ready to expand. Okay, and when we expand x plus 1, x plus 2, we get x squared, that's our x squared term. We get plus 3x, that's our x term in the middle, and we get plus 2 on the end, that's our constant term. Okay, numbers on their own, remember, are called constants. They are constant. They don't change. And when we expand this one, x plus 1, x plus 3, we get x squared plus 4x plus 3. And so on. I'm not going to read every one. What I want you to look at, I want you to see if there's a connection between the numbers inside the bracket, because we need to work those out. If we're going from this quadratic expression back to these double brackets, we need to work out what goes inside these brackets. So you need to work out where does the plus 5 come from and the plus 2 comes from, and also the x in each of the brackets. Okay, now you may spot that the x in each of the brackets comes from the fact that we've got an x squared term. So when you multiply those two x's together, that's how we get our x squared. So if we're factorising a quadratic expression where we only have x squared, then obviously we're going to need an x at the front of each of our brackets. Otherwise, when we multiply them, we won't get our x squared term. Okay, so the x times the x gives the x squared. But what I want you to look at is look at these two numbers here, the coefficient of x and the constant term, and see if you can spot a connection between those two and these two numbers inside the bracket. Because remember, we are going from this quadratic expression here, factorising that is going back to the brackets. Okay, can you spot a connection? I'm going to reveal what the connection is in a few seconds. Just want you to have a little look for a second. Okay. Have you noticed then, if we look at this first one, x plus 1, x plus 2, if we add the two numbers, we get this number here in front of x. Plus 1 plus 2 is plus 3. Let's check that out with the others. Plus 1 plus 3, yeah, plus 4. Plus 1 plus 4 plus 5. Plus 2 plus 3 is plus 5. Plus 2 and plus 4, 6. 2 and 5, 7. 2 and 6, 8. Alright, so the two numbers in the bracket always add up to the coefficient of x. Plus 5 plus 2 plus 7. Yeah. Okay. But what about the constant term? How can we make the constant term with these two numbers? Is there a connection? If you look closely, if we multiply them, so 1 times 2, 2. Yeah. 1 times 3, 3. 1 times 4, 4. 2 3s, 6. 2 4s 8, 2 5s 10, 2 6s 12. Yeah, if we multiply the two numbers in the bracket, we get the constant term. Okay, now if you remember, another word for multiply is product. Okay, product. I'm going to just do that again. Make it tidy. Apologies. Okay, let's start again. Product equals multiply. Okay, and sum also is a word for add. And this is what I need you to remember, is product and sum. Turn off this here. Product and sum. So product means multiply, sum means add. So the product of these two numbers gives me the constant term, and the sum of these two numbers gives me the number in front of x. Okay, so let's see how I can apply that product and sum to an example. Alright, it'll become a bit clearer when we start looking at an example. So if I pick another expression, so let's look at example 1. Okay, example 1. So factorize. Remember, that's what we're doing all the time. Factorize x squared plus 7x plus 12. Okay, x squared plus 7x plus 12. I'm keeping everything positive, so we don't need to worry about negatives and things like that. All right, they're going to come later. All right, so we're just keeping it nice and simple. So if I'm factorizing that quadratic, I know I need two sets of brackets, and this little number is just a way of reminding me. It doesn't mean two sets of brackets, it's x squared, but when you have a quadratic expression you always have an x squared term, so it's just a little reminder that, oh, I need two sets of brackets when I'm factorizing a quadratic. When it's a typical quadratic, a squared term, just a term to the power 1 and then a constant term. Right, so like I said above here, we know we need an x in the front of each of the brackets, otherwise I'm not going to get my x squared when I multiply those two brackets out. So x times the x squared, so I know that. So all we have to work out are the two numbers that go with our x terms inside the bracket. Now the way we work out these two numbers is from what we spotted above in the table about product and sum. We know these two numbers that we're trying to find, the product, okay, will be plus 12, the constant term, and the sum of the two numbers will be plus 7. So we know that from looking at this table and discovering, oh yeah, if I multiply the two numbers I get the constant, if I add the two numbers I get the number in front of x. Okay, so these two numbers we know multiply to equal plus 12 and add to equal the number in front of x, the coefficient of x. Right, so how do we work out those two numbers from that? Well, we start with the products. Okay, you always start with the products. So you look at two numbers that multiply to equal 12. Product means multiply, remember? And if you think about it, what we're writing down are factor pairs. All the pairs of numbers that multiply to equal 12 are the factor pairs of 12. Okay, so we've got 1 times 12. I'm just going to write them all for now. 2 times 6 is 12. 3 times 4 is 12. And I think that's it, isn't it? There's no other factors of 12. We got 1, 2, 3, 4, 6 and 12 are the factors of 12. And in pairs, 1, 12, 2 6s, 3 4s. Now, once we have the factor pairs of our product, we then look at each pair and see which pair adds up to 7. And it's obvious. it's the 3 times the 4. Okay, 3 plus 4 equals 7. So the product of 3 and 4 is 12. The sum of the two numbers is 7. So those are the two numbers that go inside my brackets, like so. It doesn't matter where I put them. I could have put plus 4 there and plus 3 there, because you're still going to get the same answer, aren't you? And the order doesn't matter when you're multiplying. So x plus 3 times x plus 4 is the same as x plus 4 times x plus 3. And there we have it. We've just factorized that quadratic expression. And if you wanted to, you could test it out. X times x, x squared. X times 4 is 4x. 3 times x is 3x. 4x and 3x, 7x. And 3 times 4, 12. There we go. I just did a quick check, quick multiplying out. And when you get really good at multiplying out, you will be able to check it quickly like that. Let's look at another example. Okay, product and sum. Alright, this is the method we are using. Okay, factorize. X squared. I'm going to keep everything positive still. And we're going to have 10x plus 21. So we've got x squared. Okay, coefficient of x squared is only 1. The next video is where the numbers will be bigger than 1. Plus 10x plus 21. So a little bit quicker this time. Two brackets. I know there's got to be an x in front, because x times the x gives me the x squared. Now I've just got to work out the two numbers. And what do I know about the two numbers? I know their product will give me the constant term, which is plus 21. And I know the sum of those two numbers, when I add them up, I'll get plus 10. Okay, let's look at all the numbers that multiply to equal 21. So all the pairs of numbers. The factor pairs of 21. 1 times 21. 2 times 3 times 7. 4, 5. I think that's it. 21 only has 4 factors. 1, 3, 7 and 21. And which pair of factors add up to equal 10? Yeah, 3 and 7 obviously. Okay, let's just write it on the side just to show you. So 3 plus 7 is 10 and 3 times 7 is 21. So there's my two numbers that I put in there. Everything's positive because everything's positive up here. And there we have it. Okay. Let's look at another one. Okay. I'm going to throw a negative in here now. Factorize. X squared minus 2x minus 15. So I'm chucking in two minuses instead of two pluses. So what do? Same method. Pair of brackets. There's 2. Reminds me to put 2 sets of brackets. Right, 2 pairs of brackets. Pop an x in, because the x times the x gives me x squared. Now the two numbers that I have to work out are such that the product of those two numbers is minus 15. So the product of two numbers is now minus 15. And the sum of the two numbers is minus 2. Okay. Now, if we're going to multiply two numbers together and we get a negative answer, we get a minus, then we know one of them is plus and one of them has to be minus. Or one of them's minus, one has to be plus. You're only going to get a negative answer when you're multiplying two numbers together if one of them's plus and one of them's minus. Okay, so we're going to have a lot more different examples here, but as we go along now, we're going to check to see which pair add up to equal minus 2, because we might get there sooner rather than later without having to write down all the factor pairs, and that's what you would do once you get experienced. So 15, we've got 1 times minus 15. Okay, does that add up to equal minus 2? No. Okay, we've also got minus 1 times 15, so we'll swap the signs. So that is different to 1 times minus 15, obviously. The 1 is negative this time and the 15 is positive. Do those two add up to equal minus 2? No. Okay. What's the next factor pair? 2 times something? No. 3 times something. So 3 times minus 5 to get minus 15, or minus 3 times 5. That'll give me minus 15, so I've just swapped the signs around. So let's check. Do these two add up to equal minus 2? Well, 3 added to minus 5. Oh, it's minus 2. There it is. There's my factor pair. Right, this one then I don't need, because if I add those two up, I'll get plus 2, not minus 2. Okay, minus 3 added to 5 is 2. 3 added to minus 5 is minus 2. So those are the pair we need. So 3 times minus 5 is minus 15. 3 added to minus 5 is minus 2. Those are the two numbers I need. So the 3 is positive and the 5 is negative. Okay, and we can double check. X times x, obviously x squared. X times minus 5 is minus 5x. Let's write this down. Then plus 3 times the x is plus 3x. And plus 3 times minus 5, plus times a minus is a minus, 3 5 15. Minus 5x plus 3x is minus 2x. So we've checked there, okay, to see if it multiplies out and does equal the expression it started off as, which it does. Okay, so you've just got to be a bit more careful when you have negatives. Let's have a look at another example where we have a mixture of positives and negatives. So example 4, factorize. I'm going to write it again this time. Let's have a think then. So I want plus 4x minus 21. Okay, plus 4x minus 21. So how do we start? We put a pair of brackets. Remember the little 2 there reminds us to put 2 pairs of brackets. Okay, pop an x in the front of each one, leaving 2 gaps for 2 numbers that we need to find. What do we know about those 2 numbers? The product, p, is minus 21, and the sum of those 2 numbers is plus 4, the coefficient of x. Okay, let's write down all the products that give us minus 21. So we do 1 times minus 21, or minus 1 times 21. So one of them's plus, one of them's minus, one of them's minus, one of them's plus. We'll swap it around. Do those add up to 4? No, they don't add up to 4. So now we'll try the next one. 3 times minus 7, or minus 3 times 7. 3 plus minus 7 is minus 4, so it's not that one. Minus 3 plus 7, that's it. That equals 4. Okay, if you add up minus 3 and 7, you get 4. So those are the 2 numbers we need in our brackets. Right, no sign in front means plus, remember. And there we have it. And if I quickly check that, x times x, x squared, minus 3x plus 7x is plus 4x, and minus 3 times plus 7 is minus 21. Okay, that's it for now. You'll be having a little practice after this. That's the best thing to do next, is to practice expanding those brackets. Factorizing those quadratic expressions. But the key words are product and sum. Remember, it all came from looking at, well, what happens when we multiply 2 sets of brackets, when we expand double brackets, looking at what we got to see if there was a connection between the 2 numbers and the numbers we had in our answer, in our quadratic expression. And there was. If we multiply the 2 numbers, their product, we get the constant. If we add the 2 numbers, their sum, we get the coefficient of x, the number in the middle. Okay, hope that helps. Thank you very much.